So now the not difficult problems, basic problems on light, geometrical optics, sheet titled Get Enlightened. Now the first problem of the sheet is about an incident ray, angle of incidence I, getting reflected from a plane surface. This is the reflected ray. Angle of incidence is equal to angle of reflection. We need to plot deviation versus angle of incidence. We need to plot deviation versus angle of incidence very clearly. If the reflection didn't take place, this would have been the ray. Therefore, this must have been the deviation. The deviation then is pi minus 2i. That's the deviation that the ray has undergone. And therefore, deviation versus I is a straight line with slope minus 2. With a slope minus 2. Obviously, when I is 0, deviation delta. When I is 0, deviation is pi. Obviously, you know. This is how it goes. This angle is theta. Tan pi minus theta is the slope of this line, which is minus 2. So tan theta must be 2. Deviation versus I is a slope is a line with slope minus 2. Tan theta therefore is 2. So that's a variation of deviation with angle of incidence. I'm assuming you would have got this right. So obviously, you know, you have option A correct. Option A correct, isn't it? Theta is tan inverse 2. Theta is tan inverse 2. Option A is correct. Clear? Shall we move to the next problem then? The next problem is about a glass slab. This is a glass slab, and it's known to be made of material of refractive index 2. There is a reflector at the bottom. There is an incident ray like this. Incident, known to be incident at an angle of 45 degrees. This ray, rarer to denser medium, it will bend towards the normal, right? It will bend towards the normal. And then it gets reflected on the surface. This is the reflected ray. And we want to be able to obtain the total deviation when it emerges. All right, we want to be able to obtain the total deviation when it emerges from the glass slab. Clear? Okay. First things first, this angle is R. So mu sine R is sine 45 degrees. So that makes, in a sense, R available to us, sine R is 1 by 2 root 2. Sine R is 1 by 2 root 2. Okay. Now, this angle is R. What is this angle? R. Angle of reflection? R. Right? Now, on this surface, realize, on this surface, 90 minus R. That's theta. That's theta. Angle of incidence on the surface. Now, if this theta is less than critical, if less than the critical angle between the pair of media, it will emerge through this face. If it's greater than or equal to the critical angle, it will get totally internally reflected. That is what would happen, right? So let's obtain sine theta and see if sine theta is more than the critical angle, sine of the critical angle, or less than the sine of the critical angle, right? So what is the critical angle for this pair of media? Sine theta c is half 1 by mu. right? What is sine theta here? Sine theta is sine 90 minus r, which is cos r, right? Cos r is root 1 minus sine square r. Cos r is root 1 minus sine square r. So root 1 minus 1 by 8, which is root 7 by 2 root 2, root 7 by 2 root 2, right? Now, I just need to see whether sine theta is more or sine theta c is more, right? Very clearly, root 7 by 2 root 2 is more than half. Do you see that? Is more than half. Because root 7 by root 2 is root 3.5, which is more than 1. So this is half into a number more than 1, which is clearly more than half. Which is clearly more than half. Yes or no? So this is true. That means sine theta, which is this, is more than sine theta c. And this angle of incidence here is more than the critical angle between the pair of media. And therefore there is going to be total internal reflection here. There is going to be total internal reflection here. This angle will also be theta, which is 90 minus r. And this angle therefore would be 90 minus theta. Do you realize that? This angle is going to be 90 minus theta. But 90 minus theta is r. So if this angle is r, which is the same as this angle, then to preserve the mu, it will get refracted at 45 degrees, isn't it? If this is 45, this is r. If this is r, this has to be 45. Snell's law, right? This is 45. That means the incident ray and emergent ray, as you can see, are parallel to each other. If the incident ray and emergent ray are parallel to each other, deviation is 180 degrees. Deviation produced is 180 degrees. So total deviation produced is pi radians or 180 degrees. That's a total deviation produced. I'm hoping you got it right all by yourself as well, right? Obviously, you know, what you might have to begin with imagined is that this ray gets refracted into this medium. In the process, if you chose to apply Snell's law at this point and find the angle of refraction, then the sign of the angle of refraction would have turned out to be greater than 1, which would have led you to believe that this refraction is not possible on the surface. You know what I'm saying? And therefore, your conclusion could have been, is this what you got? Right? Because you assumed it's going to be refraction here, and sign of the angle of refraction you ended up getting greater than 1, and therefore you were obviously prompted to believe that this refraction never occurred. There must have been a case of total internal reflection on the surface, and then of course everything followed suit. Yes or no? Right? So total deviation produced in this situation is 180 degrees. Clear? Yes, please. Yes, of course. So that's a limiting case. That's a limiting case where it grazes on the surface at theta equal to theta c, angle of refraction. That is still the limiting case of refraction, where angle of refraction becomes 90 degrees. So that's not internal reflection. That's still refraction. That's still limiting refraction. So if I have So my friend, from denser to rarer medium, if this is incident at theta c, then this would be, angle of refraction would be 90 degrees. So this still is, that still is refraction. That still is refraction. Yes, yes. If this angle is slightly more than theta c, say if this is theta, which is slightly more than theta c, then there is going to be this theta and this theta. Yes, of course, of course. Yes or no, right? Let's proceed to the next. So far so good, right? Can I wipe this off? Problem number 3 of the sheet is about two plane mirrors inclined. These are two plane mirrors. This is perpendicular to the horizontal mirror. This is a line perpendicular to the horizontal mirror. And this angle is, this is 90 degrees, this is 30 degrees, right? And there is a point source of light here. There is a point source of light here, right? There is a point source of light here. And there are three observers, A, B, and C. A is located somewhere here. B is located somewhere here. And let's say C is located somewhere here. C is located somewhere here. Obviously, you know, there are two images formed of S. One by this mirror, one by this mirror. Now the problem inquires, which of the three observers will see only one image? Which of the three observers will see only one image? There are two images formed, isn't it? Or nahi? One image of S formed by this mirror is this, say S1. Object distance is image distance formed by this mirror, right? The other image would be formed by this mirror. The other image would be formed by this mirror. This is S equal to S2, right? These are two images formed. Now, look at A. See, if there is a reflected ray that can come, that seems to be coming from the image to an observer, then that image is seen by the observer. You know what I'm saying? From the image, if suppose this is the image, if I can conceive of a reflected ray from this mirror coming to A, then A can see S1. Yes, I can conceive, isn't it? I can conceive of a reflected ray like this. If this is the incident ray, this has to be the reflected ray. So I can conceive of a reflected ray which seems to be coming from S1, and therefore S1 will be visible by A. You know what I'm saying? So after all, you know, all rays of light that are getting reflected from, let's say, this mirror 1, they would look like coming from S1, right? So there indeed is a ray that seems like coming from S1 and hitting the eye of A. So A will witness S1 for sure. A will witness S1 for sure. Now same thing. This was S2, right? A is here. And there indeed I can conceive of a ray of light. I can conceive of a ray of light that seems to be coming from S2. That seems to be coming from S2. A reflected ray. And therefore S2 would also be visible by A. S2 will also be visible by A. Yes or no? Therefore S1, A can see two images. A can see two images. Similarly, you see, there is a line of action joining B and S1 passing through, intersecting this mirror. Yes or no? There is a line, see? Can you see this? So there is a, if this is an incident ray, this would be a reflected ray, which seems to be coming from S1 and hitting B. So B will see S1 for sure, right? And are you all okay with this? Huh? I don't want you to be messed up on this concept. Okay. And similarly, just to remove the clutter from here, do you also believe that if B is here, I can conceive of a reflected ray coming from S2 via this mirror M2? This was the mirror M2, right? I could have conceived of a reflected ray like this, incident ray, reflected ray, which hits B and seems to be coming from S2. So B will see S2 as well. So B will see S1 as well as S2. A will see S1 as well as S2. Two images. Now let's look at C. Let's look at C. So far so good, right? this is S2. Hey, yes, C will see S2 for sure, because I can conceive of a reflected ray like this, which seems like coming from S2. So C will see S2 for sure, but will it see S1? Can I get a reflected ray from S1, which seems to be coming from S1, reaching C? No, no. Can you think of any? See, join C and S1. It's coming from mirror 2. It's not coming from mirror 1. Right? See, if you might be tempted to believe, hey, this is a reflected ray, but that's S1 is because of mirror 1 and not of mirror 2. So this ray, which would have liked to come from S1 reaching C, should have got reflected from mirror 1. But it's not getting reflected from mirror 1. So C will not see S1, C will see S2. So C will see only one image. C will see only one image. Yes or no? Are you all okay with this? Right? So A will see two images, B will see two images, but C will see only one image. Right? Now, there is a mirror which about this point is undergoing a rotation at 10 revolutions per second, right? There is an incident ray, incident at the point P, right? This is an incident beam, and it is rotating about P at the rate of 20 revolutions per second in this sense, right? Now there is this reflected ray. We want to be able to find the rate at which the reflected ray rotates, the rate at which the reflected ray rotates, right? Now one thing, look at the effect of the mirror alone. If this was the incident ray, and the mirror rotated in this sense at the rate of 10 revolutions per second, right? Then if the mirror rotates in this sense, that means the normal will rotate also in the same sense, and then the reflected ray will rotate at 2 omega. Yes or no? The reflected ray will rotate at 2 omega. That means it will rotate in this sense at the rate of 20 revolutions per second. Isn't it? If the mirror is rotated by an angle theta, the reflected ray rotates by 2 theta, right? So that's the effect of the mirror alone. The reflected ray will rotate in this sense at the rate of 20 revolutions per second. Now, imagine the mirror to be fixed. Imagine the mirror to be fixed. And this is my incident ray. This is my reflected ray. Now, very simple. If the mirror is fixed and if the incident ray is rotated in this sense by a certain angle, the reflected ray will rotate in this sense by the same angle. Would you not want to believe that? If the mirror is fixed and the incident ray is rotated by 20 degrees here, then the reflected ray will rotate by 20 degrees here. If the mirror is rotated by 5 degrees here, the reflected ray will rotate by 5 degrees in the opposite sense. Yes or no? That means if this has an angular speed 20 revolutions per second like this, then the reflected ray would have 20 revolutions per second in the opposite sense. That means now the combined effect is 20 revolutions per second like this because of the mirror, and 20 revolutions per second in the opposite sense because of the incident ray. That means net omega for the reflected ray is 0. So omega net for the reflected ray is 0. Superimposing the impact of rotation of the mirror and rotation of the incident ray in opposite senses, it's going to be 0. Yes or no? There is mirror M1. This face silvered. This is mirror M2. This face silvered. There is an object O 7 centimeters in front of mirror 1, right? And the separation between the two mirrors is 10 centimeters. How many images are formed? Only one image. Only one image would be formed, because there would be no reflection from mirror 2 at all. There would be no reflection from mirror 2 at all. So this is an object, and there is going to be its image I, which is 7 centimeters. Yes or no? So only one image formed. Obviously, only one image formed, right? the next problem number 6. Problem number 6 is about an object O at a distance x1 from the focus. Its image I is formed at a distance x2 from the focus. Right? Real image. So obviously the object cannot be between the pole and the focus. The object could not have been between the pole and the focus, because then the image would have been virtual. Right? So object is obviously to the left of the focus at a distance x1 from the focus. Its image is formed at a distance x2 from the focus. F is the magnitude of the focal length of the concave mirror. We want to be able to find F in terms of x1 and x2. Right? So very clearly, if F is the magnitude of the focal distance, then object distance, our convention is distances from the pole in a direction opposite to the incident ray positive, in the same direction as incident ray negative. So object distance is going to be F plus x1. F plus x1. Image distance is going to be F plus x2, positive. F is the magnitude of the focal length, which is, now I'm going to use the mirror equation. 1 by V plus 1 by U equal to 1 by F. 1 by V is 1 by x1 plus F plus 1 by x2 plus F is equal to 1 by F. Now it's about solving for F. What's the best way to solve for F? The best way to solve for F here is transpose one of the two terms on the right hand side. Transpose one of the terms on the right hand side. That's the best way to solve for F. So I end up getting 1 by x1 plus F equals, when I transpose this, I get x2 divided by x2 F into x2 plus F is what I get. Right? When I transpose this on the right hand side, then this becomes the difference. Right? Now realize that fx2 will get cancelled with fx2 here, isn't it? If I multiply, fx2 will get cancelled with fx2 on cross multiplying, and I get x1 x2 equal to f squared, F therefore is root x1 x2. F therefore is root x1 x2. How did you guys solve? Same way, right? No, that's all right. That's all right. I mean, the diagram would have been necessary so that, you make sure that the image is formed to the left of F. Because if the image were to be formed to the right of F, then the image distance would have been F minus x2. Just to make sure that it is F plus x2, it was important to be able to draw the ray diagram. Right? Refer to problem number 7. They give you a prism whose angle of minimum deviation is delta. That means if there is a ray of light coming like this is an incident ray, this is a refracted ray, and this is an emergent ray. Now what's given is the angle between incident ray and emergent ray is delta, and the minimum such angle is delta. Minimum such angle is delta by the prism. Now I have 3 such identical prisms. What's the minimum deviation produced by a combination of 3 such prisms? 3 such prisms. Now, this prism in this sense, oriented this way, would produce a minimum deviation delta clockwise. Right? But if it were to be like this, then it would produce delta anti-clockwise. Yes or no? So based on the orientation. So if I have 3 identical prisms like this one would produce delta clockwise, so plus delta. This one would produce delta anti-clockwise, so minus delta. And this one would produce delta clockwise. So the net deviation produces delta minus delta plus delta. Effectively, it produces a minimum deviation delta. Yes or no? Right? So the minimum deviation produced by 3 such identical prisms is going to be delta. If we orient them in this manner, plus delta, minus delta, plus delta, because of the direction sense in which deviation is going to be produced. Right? Now, The next problem is again about a prism. Given that the prism is equilateral, that means this is 60 degrees, and the angle of incidence is equal to angle of emergence. Angle of incidence is equal to angle of emergence, 3/4 the angle of the prism, so 45 degrees. I want to be able to find the deviation produced by this prism. Very clearly, the deviation produced by the prism is I plus I prime, which is I minus angle of the prism, 60 degrees, isn't it? I plus I prime, in this case I prime is equal to I, right? That's a result for deviation of a prism through a prism. I plus I prime minus A. So 2I 90 minus 60, that means 30 degrees is the deviation produced by this prism. Very simple, isn't it? Right, so there is a prism given to you whose refractive index is cot A by 2. Angle of the prism is A, and we want to find the angle of minimum deviation. So this again is based on a result which is like refractive index of the prism is going to be sine of A plus delta min by 2 divided by sine A by 2, right? Isn't it? Where mu is given to be cot A by 2. A by 2. Now very clearly this is very clearly this is cos by sine, this is cos by sine, sine will get cancelled, and then we have cos A by 2 as sine A plus delta min by 2, and this cos A by 2 can be written as sine 90 minus A by 2, right? And therefore equate the angles. We get A plus delta min equals pi minus A, and delta min therefore would be pi minus 2A. Delta min therefore would be pi minus 2A, right? The next problem is about a prism of angle A. There is a ray of light incident at an angle 2A, hits the mirrored face and retraces its path. That means it must hit the mirrored face, normal to the mirrored face, so that it could reverse its trajectory, right? So that it could reverse its trajectory. We want to be able to find the mu of the material of which the prism is made of. Now, very clearly, if this is 90 degrees, this is 90 minus A, and this therefore would be A, and now very clearly mu is going to be sine I by sine R, sine 2A divided by sine A, sine 2A divided by sine A, which is 2 cos A, right? So there is a prism with angle 90 degrees. There is a prism with angle 90 degrees. And we want to be able to find the maximum value of the refractive index of the prism, mu max, for which rays of light will be able to emerge from the prism. Right? Now very clearly, the result that you want to know is there is a limit on A, so that rays of light could emerge from the prism. As long as A is less than or equal to 2 sine inverse 1 by mu. Remember this result? As long as A is less than or equal to 2 sine inverse 1 by mu, rays of light will be able to emerge from the prism. If A becomes greater than this number, then no matter what the incident ray is, no ray of light will be able to emerge from the prism. Right? You know this result, right? This is the limiting angle for which rays of light will emerge from the prism. If A becomes in excess of 2 sine inverse 1 by mu, then no ray of light incident on the prism can ever emerge from the prism, right? So A by 2, which is 45 degrees, pi by 4 less than or equal to sine inverse 1 by mu, A equal to 90 degrees. That means 1 by mu will be greater than or equal to sine 45, which is 1 by root 2, right? Or mu less than or equal to root 2. That means mu max is root 2. Mu max is root 2. As long as mu is less than or equal to root 2, then for this angle of the prism, you will find emergence from the prism. You would find emergence from the prism. Clear? So we have a situation here where there is a spherical drop, refractive index mu, surroundings air, right? There is a ray of light which is incident at an angle phi, sees the center, so this must be the normal at the point of incidence. And on this surface, it's incident at an angle alpha. All right. Now the question is, first part of the problem is whether rays of light will get totally internally reflected or not. Whether rays of light will get totally internally reflected or not. Right? Now that's going to happen if alpha were to be more than the critical angle. If this angle were to be more than the critical angle, there would be total internal reflection. Otherwise, there is going to be combination of reflection and refraction. Both will happen, right? Now, evidently, if this angle is alpha, then this is an isosceles triangle. This angle is also alpha. So very clearly phi is not 90 degrees. So alpha has to be less than critical. So alpha has to be less than critical angle. Yes or no? Alpha has to be less than critical angle. Yes or no? I'm saying for alpha to have been critical or more than critical, then this angle, this phi alpha combination wouldn't have existed, isn't it? That means if a ray of light went like this, it would have gotten refracted like this. Therefore, obviously alpha is not critical angle. Alpha is not critical angle. It's certainly less than critical angle. Do you all understand that? Because if you reverse the direction of ray, if this becomes angle of incidence, this becomes angle of refraction phi. So obviously phi is less than 90 degrees. Therefore, alpha has to be less than critical angle for the pair of media. Yes or no? So obviously there will not be total internal reflection here. There will not be total internal reflection at A. Okay. However, some incident energy will still get reflected. Some would get refracted, some would get reflected. So some internal energy gets reflected based on laws of reflection. If this is angle of incidence, this is going to be angle of reflection, right? This is the normal at the point of incidence. This angle is alpha, so this angle will also be alpha. And then alpha and phi will preserve the relationship to maintain mu. So this would be phi. Now, the total deviation produced in the process. The total deviation produced in the process, well, phi minus alpha for this surface, clockwise. Phi minus alpha, clockwise. Clockwise. Okay. Then for this, pi minus 2 alpha clockwise, pi minus 2 alpha clockwise, isn't it? This is pi minus 2 alpha clockwise. Clockwise. Then for this, realize it's going to be phi minus alpha again. It's going to be phi minus alpha once again for this, right? Clockwise. So phi minus alpha again clockwise. That's going to be the total deviation produced. That's going to be the total deviation clockwise produced for this arrangement. So this turns out to be pi minus 4 alpha plus 2 phi. Pi minus 4 alpha plus 2 phi. That's the deviation produced. Yes or no? Different values of phi will give me different values of alpha, and therefore you'll get different deviations produced. This is the expression for deviation in a situation shown. Now I want to be able to find phi. The last part of the problem, model phi so that delta becomes delta min. So that delta becomes delta min. Right? I want to be able to find phi such that delta becomes delta min. Now, if I apply Snell's law at this point, 1 into sine phi is mu into sine alpha. Sine alpha. Mu sine alpha. Right? 1 into sine phi is mu into sine alpha. Now, for delta to be delta min, d delta d phi must be 0. For delta to be delta min, delta is a function of phi. Alpha is also a function of phi. So, for delta to be minimum, d delta d phi must be 0. D delta d phi must be 0. Yes or no? Must be 0. Right? So if I differentiate this with respect to phi, I end up getting minus 4 d alpha d phi. 4 d alpha d phi plus 2 is 0. This is what I get. So this gives me like a d alpha d phi as half. Right? For deviation to be minimum, d alpha d phi must be half. Now, I have to eliminate alpha and find phi. I have to eliminate alpha, find phi. Given that d alpha d phi is half, for d alpha d phi to be half, what should be phi? That's a new question. For d alpha d phi to be half, what is phi? That's a question, isn't it? Now, this is Snell's law applied at the point of incidence. Let me differentiate both sides with respect to phi. Let me differentiate both sides with respect to phi. This is equation 1. I end up getting cos phi is mu cos alpha d phi. When I differentiate this with respect to phi, cos phi is mu cos alpha d phi. Yes or no? Hey, but d phi is half. So this gives me like a cos phi, 2 cos phi, right? This 2 will come here. 2 cos phi is mu cos alpha. Yes or no? Right? D phi is half. Will give me 2 cos phi is mu cos alpha. I need to eliminate alpha and solve for phi. Square and add 1 and 2. Square and add 1 and 2. So mu square sine square alpha plus mu square cos square alpha, that's going to be mu squared, is sine square phi plus 4 cos square phi. Yes or no? If I square and add 1 and 2, if I square and add 1 and 2, I end up getting sine squared phi plus 4 cos squared phi equals mu squared. Write sine square phi as 1 minus cos square phi. Write sine square phi as 1 minus cos square phi. So you get 3 cos squared phi is mu squared minus 1. Writing sine square phi as 1 minus cos square phi, or cos squared phi, such has to be phi. Phi as mu squared minus 1 by 3. This is what happens. Such has to be phi. Such has to be phi. Yes or no? Right? So, we have an empty tank here, not filled with anything. Alright? And L and L, that's the length of the tank and also the width of the tank. Okay? That's given to be 5 centimeters. And there is an eye whose line of vision sees this point, this end, this corner. It can see this corner, right? But obviously, it can't see C. It can't see C, right? There is an insect at C, the mid of the base. There is an insect C at the mid of the base. And now what we want to be able to do is, we want to be able to fill this tank with a transparent substance of refractive index mu equal to root 5 by 2, so that this eye can see the insect at C. We now want to be able to fill this tank up to a certain height with a liquid of refractive index root 5 by 2, so that the insect at C is visible to the eye, so that the insected C is visible to the eye. This is what I want to be able to do. Yes or no? Right? Question is, how much should we fill it up with? Now, one thing for sure, some very simple things. This is L, so this must be 45 degrees, as you can see, right? This also is 45 degrees, corresponding angles, ordinary geometry, right? Now what I seek to do is, I seek to fill this tank up to a height h. I seek to fill this tank up to a height h. Right? I seek to fill this tank up to a height h. There is liquid here. Refractive index mu equal to root 5 by 2. And I want this C in turn to be visible to this I. Now, therefore, what is it that I want? There is a ray of light that starts from C in this medium, and after refraction, I want this ray to assume this path. If this is the incident ray in the medium, I want this ray to go and hit the eye there. Such has to be H. Yes or no? Now, essentially then, again, not difficult to observe. This is 45 degrees, this is 45 degrees. So angle of refraction, in any case, no matter what height you fill it up with, the angle of refraction has to be 45 degrees. That's certain, right? Because this angle is equal to this angle, and this is 45 degrees. Yes or no? Now, question is, to get angle of refraction 45 degrees, what should be the angle of incidence? What should be the angle of incidence so that angle of refraction becomes 45 degrees? So let me deploy Snell's law at this point. So mu into sine I, mu, which is root 5 by 2, into sine of the angle of incidence, sine I, equals sine 1 into sine 45 degrees, which is 1 by root 2. Sine I is such that sine I is 1 by root 5. Yes or no? Now realize that this height is h, right? This is 45 degrees, so then this also has to be h, isn't it? This is a right angled isosceles triangle, 45 degrees, 90 degrees, 45 degrees, so h and h, this is h. Yes or no? Now, what is AC? AC is L by 2. AC is C is the midpoint of AB. C is the midpoint of AB. So AC would be L by 2. AC, as you can see, is L by 2, which is 5 by 2 centimeters. Right? CD, therefore, would be H minus L by 2. CD, therefore, would be H minus L by 2. H minus, right? This is H minus L by 2 is CD. Now, tan I is CD by H. Tan I is CD by H. CD, tan I is CD by H. Yes or no? Hey, but if I know sin I, I know tan I. Tan I then would be 1 divided by root 5 minus 1. That is half. I hope you realize that. Tan I would be half if sin I is 1 by root 5. So this is half cross multiply, h therefore turns out to be 5 centimeters. That means you must fill it up completely. You must fill it up completely. See, in problems, sometimes they would give you a situation of this kind. They will say, there is an insect which is moving and there is a tank which is being filled. So they'll say, okay, if the tank is being filled with a certain cubic centimeters per second, then what must be the velocity of the insect so that the insect is visible to the eye at all times? That's a variation to this problem only. All right.